Hi everyone. So chapter 1 of your textbook is really just trying to convince you that data visualization is an important thing to know and to use. Here's a fun fact. 50% of the human brain is dedicated directly or indirectly to processing visual information. That means that our default is to visually process information. Let's test this for a second. How long does it take you to find the peak in this data, the biggest number? There's only one peak. And how long does it take you to find the peak in this data? Most of you were able to see the peak in that bar chart far faster than the table. That's just the way your brain is designed. If you want to test another way that your brain is designed to visually process information, then take a moment to stand up, walk away from your desk, stand on one leg, and close your eyes. Now, what you'll notice, most likely, unless you're a dedicated yogi, is that it's really hard to balance on one leg with your eyes shut. And that's because your brain uses so much information that is visual to help you balance. And we never consciously recognize all of this visual information that our brain is processing. Data visualization is ultimately communication. As your textbook author likes to say, data visualization is about finding the point in the data and making sure that's conveyed directly to the audience. Because humans are natural processors of visual information, data visualization is more of our first language when it comes to numbers than the numbers themselves. Data visualizations help us to overcome language barriers. We don't need to understand the words accompanying a chart in order to get the gist of the chart because the shapes, the images, they speak to us. In the same way, data visualizations help us overcome our statistical literacy because the visual implication of what's happening is far easier to process than the statistics themselves that rendered the graph. But because we are so quick to create meaning from visual information, data visualizations can also be somewhat dangerous. And this danger comes when visualizations are created in a misleading way. Now, sometimes this happens accidentally. Take a look at this image. We have a pie chart here in which the wedges all add up to equal over 100%. That means this is nonsense. It's misleading. I don't know, but I would guess that whoever designed this chart didn't mean to mislead us. I would say that they probably had a survey where they asked a certain number of people whether or not these three worries applied to them. And 62% of the whole said yes to family getting it, 48% said yes to getting it themselves, and 68% said yes to the economy. Well, if we want to show that information as a pie chart, that's three separate pie charts showing the parts of the whole that said that was a worry for them versus not a worry. So I would assume this was accidental. But other times I see data visualizations that are misleading, and I think they're intentional. For example, when I see a data visualization in which a y-axis doesn't start at 0, I'm immediately suspicious of the person that created it because the only reason to take a chart and cut off the origin is to make it look like there's a bigger difference in the overall quantities than there really is. So my hope is that throughout this class, you learn to start thinking of data visualization as a way to communicate data. And that as you're designing data visualizations, you think about not just what the point is, what the absolute overall purpose of your message is, but also the potential ways that the data could be presented misleadingly so that you make sure you are always conveying the most ethical, accurate, correct message to tell your story.